Okay, here we'll solve this set of questions. We'll revise this. So question asks, first question is methyl chloride, means it is a alkyl halide, right? It is a alkyl halide. I can write it this way, right? Alkyl halide. The first one I am writing. So alkyl halide is reacting with a sodium iodide in the presence of acetone, right? And small amount of the heat. So what does this mean? This is a Kingston reaction. This is Phil Kingston reaction. This is halogen exchange reaction. So what you are going to get is Ri plus NaX. Means in this case, what is R? R is this CH3, CH2, CH2, I. X is I, right? And this is sodium iodide. Okay, same reagent. So you are going to get CH3. Sorry, 1 minute. This is Cl. Yes, sorry. This is Cl. So the halogen is going to exchange. That's why this is called as a halogen exchange reaction. So what you get is a 1 iodo alkane. What you get is 1 iodo alkane plus NaCl. This will be a byproduct. Major product is asked. So major means you have to write only the main product, major, and this is a byproduct in this reaction. Second reaction, this is nucleophilic substitution reaction, right? So second question I'll write over here. This is CH3, CH2, CH2, OH plus SOCl2 in the presence of pyridine. Pyridine is a solvent. What is the name of this reaction? Name of this reaction is nucleophilic substitution reaction. Now, nucleophilic substitution means we have to know what is a nucleophile. Nucleophile over here is Cl minus. How it's generated? It is generated from thionyl chloride. Means this is sulfur. This is uh, like sulfur will have sulfur is a central atom. This is double bonded oxygen. There is chlorine. There is this chlorine, right? So how many electrons? Sulfur is having six valence electron. Okay, let's have some look on a chemical bonding molecular structure also. One, two, three, four, 5 and 6. This is a lone pair of electrons. So what happens is that there is a lot of repulsion between lone pair and this. There is also lone pair over here. There is also lone pair over here. So it is very easy to break this bond, to break one of the bond. So here this gives you a chloride minus as a nucleophile, Cl minus as a nucleophile. So once this is a nucleophile, it will attack a carbon now into this CH3, that is propanol, which is there, CH3, CH2, CH2OH, and this is your Cl minus. My question to you everyone, that why this chlorine is going to go and attack on this carbon only? There are other carbons also. Okay, so what is the reason for that? The reason is very simple. Reason is very simple, that carbon oxygen bond, this hydrogen which is there, if I open up this carbon, then it is this carbon, this hydrogen and this hydrogen. So attack is going to take place on the attack is going to take place specially on this carbon. Attack is going to take place 1 minute. Yeah. Attack is going to take place specially on this carbon. Why? Because this carbon is partially positive. It is connected to what? This electronegative element. Oxygen is electronegative element. These are positive, but not as positive as this. This is having maximum positive charge. So this is negative charge which is going to attack over here. The longest bond is going to break. Which is the longest bond? Carbon oxygen is the longest bond. So this is the bond which is going to break. And what is getting substituted over here? Nucleophile is getting substituted over here. So your final product over here is this CH3, CH2, CH2, Cl. That is 1 chloropropene. Right. Last one. Last one is Markovnikov's reaction. We have done this before. That Br will go here. Means in this case, I'll directly write the product. The product is anti-Markovnikov's reaction. It is CH3, CH2, 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 Br. And this is what Markovnikov's reaction. Negative part of the adding species will go to the carbon which has less number of hydrogen in a carbon-carbon double bond. So this is the double bond here. This is CH2. Here also it is CH3 and this is Br, or you can write a Br here also, one and same it is. This is CH3. Hydrogen is attached over here. That's it. Okay, this question. How will you carry out the following conversion? So first question, we'll take this. The first question is 2-bromobutane, that is 2-bromobutane. I need to convert it to but-2-ene. But-2-ene. Understand. First, we'll write the structure of 2-bromobutane. 1, 2, 3, 4. These are the four carbons. Butane means I have written a four carbons over here. 2 bromo means on second position. You can put it here or you can put it here, one and same. So here I am putting a bromine, right? There is nothing else. So I'll put three hydrogens. How I understand? Because there is already one bond. I need to make more three bonds to make it total four. Here already two bonds are there. I'll make two hydrogens here. Here there are already three bonds are there, so I'll put only one hydrogen here already just one. So this is what the 2-bromobutane. You need to convert this to a but-2-ene. But-2-ene means what? CH3, or I'll write this way: carbon, 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 and carbon. On second position there is a double bond. This is what it means. So here three hydrogens. Here there is one hydrogen, right? You can show it directly this way, or you can show CH and CH there itself. One and fine, one and same it is. So this is what you are getting. Okay, you can show it this way. No issue. You can show it this way. This is butane. This is what we want, right? So this reaction over here, 2-bromobutane, can be done. This reaction could be done by a beta elimination. Beta elimination, or also known as dehydrohalogenation. This reaction is very simple. It is this CH3, CH2, CH. Okay, I'll show it here. So what we need to do to for this conversion, we have to put KOH, right? And that is alcoholic. Understand this difference. This will help you a lot. See, when it is alcoholic, KOH elimination takes place. And when it is aqueous KOH or aqueous NaOH, aqueous means in water, that time the nucleophilic substitution takes place. Like Br will be substituted with OH. Since it is alcoholic, OH. So here the thing what is going to happen is that mechanism part. Let's understand the mechanism also. So I'll write a mechanism over here. It's known as beta elimination. So the reaction is this way: CH3, CH2. We'll understand both the approaches. There are two approaches for this. This is Br. One minute, I am getting one call. Okay, so I was here, I was explaining a beta elimination. So KOH, what is written over here? That KOH which we are writing, why we are adding that? It is a source of, remember that it is a source of OH minus. Now OH minus is a what? We have learned that OH minus as a base, right? Sometime. Sorry, we know that OH minus acts as a nucleophile, it attacks a carbon deficient. But in this case, since it is alcoholic, this is a base. Base means what? This is a base. Base abstracts abstracts proton. Proton means a H plus. It abstracts a proton which is a H plus. Means our OH minus is here. One possibility it will abstract hydrogen from here. Another possibility that it will abstract a hydrogen from here. So I'll write this to be A pathway. This is to be a B pathway. So what we are going to have if we write it this way, if I write what you will get if it is through A, means this hydrogen. It is this CH3 CH minus, this is CH Br and CH3. This is what you are going to get. And if it is B pathway, like if it is abstracting this, then you are going to have this CH2 CH Br, and this is CH2 minus, right? Two pathways you are going to have. This is a negative charge where it's going to move, where there is a positive. So here this carbon is partially positive, this carbon is also partially positive, where it's going to move. So this negative charge is going to move over here, and this negative charge is going to move over here. So now it is forming a new bond, double bond, means this carbon is forming a more than four bond. One bond should break, which will always break, this Br will break, and here this Br. So there are two possibilities. So here the final product will be this CH3, CH2, CH, CH2. Here, what is the main product, final product? If we follow this pathway, it is this. So here, this is major, and this is minor product, right? Reason, if we talk about the stability of the alkene, then you can, like both are alkene, which is more stable. Remember this rule, more the number of the alkyl group, more the number of alkyl group on either side, either side of double bond, more is the stability of alkene. Like if you see, there are two alkyl group. This is one methyl, and this is just, there are two methyl group. Here there is just one alkyl group, bigger. Although it is bigger, but it is just one. Here it is two. So this is more stable. Like this will be based on a hyperconjugation. This rule is there. Uh, this is called as a Sadzev rule. Okay, so you get the more substituted alkene, that is what you are going to get. So this is the major product. If you want to know more, you can just refer to my GOC video, General Organic Chemistry. There I have explained the stability of the alkenes. Okay. Next question is benzene to para nitrochlorobenzene. Okay, we'll solve this. Um, this question here is about this. You need to convert. This is your benzene. You need to convert this to para-chloronitrobenzene, means Cl over here, and para means this is para positions, and this is nitro, right? This is what you need to do. Means here two things are there. One you need to do the chlorination, and other is nitration. Means what is required for you to do? You need to do chlorination. chlorination, and second is nitration. Now, one question to you. Is it fine to do chlorination first and then nitration, or a nitration first, then chlorination? Is it going to matter, or it's one and same? You do whatever you want first, you will get the same product. Remember, see, there is something called as directive influence. You have to learn this directive influence. See, yeah, slowly we have to develop our organic chemistry base. Although we are learning for the formative, slowly we have to develop the how understanding about the organic. So it is not only about this chapter. These things are going to help you in upcoming chapters of the organic chemistry. So overall, we are building our organic chemistry base. So let's do first nitration. Okay, what I'll do is first we'll do the nitration of the benzene. Means you take a benzene and add HNO3, HNO3, and in the presence of H2SO4. What do you get? A nitro. Any position. You consider any position over here. NO2. So you'll get nitrobenzene over here. This is our nitrobenzene. Now you do this, you take this nitrobenzene and do chlorination. Means what we are doing? We are doing the electrophilic substitution. Here NO2 is a electrophile, which this is also first one is also electrophilic substitution. Now we are doing chlorination. So I'll write over here. First was nitration we have done. This is not the correct method. I'm just showing if you do nitration, what will happen. We are not going to get the same product. Here this is chlorination. This second step is chlorination. First is nitration. So chlorination, what we do? We take a chlorine and FeCl3. This is a Lewis acid. So what you get, like this group which over here NO2 group is a orthoparadiene. Sorry, it is meta directing to incoming electrophile. Meta directing to electrophile. I'll just write electrophile. It will direct a electrophile to a meta. So here where the electrophile will go, the electrophile which is Cl NO2 is going to go and get substituted over here, right? So this is not the product which we want. We want this product. So nitration first, doing first nitration is not going to work. But instead what we need to do is first chlorination and then nitration. We'll do this also. Please make a note of this. I'm just going to wipe this off. Yeah. So we'll do first chlorination. We'll do chlorination first, then nitration. So chlorination means what? You take a benzene, you take chlorine and FeCl3, what you get is a chlorobenzene, right? And once this chlorobenzene you do, now you do the nitration. Means second step, I am doing the nitration. You take this chlorobenzene, and do the nitration, HNO3. Okay, this is concentrated. Earlier also it was concentrated, and H2SO4. So what you will get is NO2. NO2 is a electrophile, so it will get substitute over here. This is major product, and minor product is this chlorine over here, NO2 over here. Because here this is minor because lot of repulsion between chlorine and NO2. Here it is less repulsion. Less repulsion, more stability. More repulsion, less stability. So this is what the answer for this my question. Benzene to parachlorism, chlorobenzene. That is, this is the product what we are getting. The name of this product is para chloro nitro benzene. Yeah, one thing I did not discuss over here is that this is why it is ortho and para, because over here the chlorine group which is attached is ortho para directing. This is ortho para directing to electrophile. Okay, to electrophile. Incoming electrophile will go either at a ortho or at para position. So this is para position and this is ortho position. So that's it. One chlorobutane to N octane. We need to do this following conversions, right? I need to do this. One chlorobutane to N octane. Means what they are saying is this one chlorobutane, how it will look. CH3, CH2, CH2, CH2. Yes. One chlorobutane. I need to convert this to N octane, that is CH3, CH2. This is N octane. This reaction is similar to this Rx. You must be familiar with this. It is given Rx, alkyl halide, and in the presence of sodium, reacting with the sodium, reaction of the alkyl halide with the metal. You can obviously you cannot you can just write this 2 and don't write this Rx. That is also possible. So in the presence of dry ether, what do you get? It is R connected to R plus 2 moles of NaX, right? So this is that 2 moles of this. You react this with sodium. You react this with sodium. I'll show this way. You react this with sodium in the presence of dry ether. So this is known as Wood's reaction. Wood's reaction. So you can do this preparation. Wood's reaction may not be asked directly, but it is asked in this form. Wood's reaction. So it is one chlorobutane to N octane. Next is but1 in to 1 chlorobutane. But1 in to 1 chlorobutane. But1 in means what? CH3, CH2, CH. So this is but1 in. You need to convert this to 1 bromobutane. Someone can guess the answer for this. You can just comment over here. You can take the pause for some time. So answer for this is HBr. And in the presence of peroxide, this is anti-Markovnikov's reaction. If you put without a peroxide, Br will go here and you will get a 2 bromo butane and not one bromo butane. So this is the answer for this. Write the structures of the major product of the following. So by looking at this, this is KOH, means it is a base we have used. Here also it is a base. This is also alkyl halide. This is also a alkyl halide, right? If I write the structure of the first one, proper structure, it is a carbon. This is CH3. This is also CH3. This is also CH3, and this is Br. So this is the reaction in the presence of KOH. It is a base. Okay. But the medium is alcohol because it is mentioned that ethanol, right? Ethanol is what? Alcohol. Examiner may not always write, alcoholic KOH. In this form, it can give you heat. right? So this is the first thing. And what is the second structure? It is second structure is this CH3. This is a carbon. This is hydrogen. Here, this is the Br. This is CH2, CH3. Here also we are using a base. Sorry, NaOH we are using. Um, So whether it is going to act as a base or nucleophile, that will depend on the medium, what medium it is. Here, water means aqueous medium. So here, this will act like a this will OH minus, no? This is a source of both are source of OH minus. This is also a source of OH minus, source of OH minus, and this is also a source of OH minus. Just understand the difference. Whenever it is alcoholic medium, this OH minus is going to act like base. And here the OH minus or OH minus in this case will act like nucleophile. So base means what? Abstraction of the proton, beta proton. So this is the hydrogen. There are three hydrogens. So I'll split this. So whole of the reaction after abstracting this, what you will get? We'll remove this. You are going to get this alkene. And what about this? This is going to attack on this carbon because it is partially positive. Going to attack on this carbon. Is going to attack on this carbon. The longer bond is going to break. So what compound you are going to get? Alcohol over here. Okay. Here this is name is 2-methyl propene, and here it is butane 2-ol. This question, this is a series of reactions. We'll do this. Like you can easily identify. This is a reaction where it is a beta elimination. First step from this to this A, it is a beta elimination reaction. So I'll just write this CH3, CH, Cl. How do I understand that? Because it is alcoholic KOH and not aqueous or not just NaOH. This is the thing. So after putting alcoholic potassium hydroxide, this elimination is going to take place. This will eliminate beta elimination. That is what we say. So here, this is CH3, CH double bond CH2. This is our product A. After A to B, what is that? HBr, right? You are adding HBr to this in the presence of peroxide. So it is going to follow anti-Markovnikov's rule. So here, what would be the answer? Br will go to the carbon which has more number of the hydrogen. That is what the anti-Markovnikov's rule is saying. So here, this is CH3. This is CH2 because hydrogen is coming to a less number of the carbon and according to the anti-Markovnikov's rule. It is this CH2. Br. So next is what? This is in the presence of sodium iodide and dry ether. Means this is a Wilkinson reaction. So I'll write the step by step from here to here, from here to here. On arrow I will write it is beta elimination. This is Markovnikov's reaction. Sorry, anti-Markovnikov's reaction from here to here. Anti-Markovnikov's reaction. This is Wilkinson reaction. Okay, you just make a note of this. This is Wilkinson reaction. What you will get? A halogen exchange, right? So iodine is getting substituted over here. That is CH2I. And NABR is a byproduct. Further from here to here, it is magnesium in the presence of dry ether. So this gives you a Grignard reagent. That is, what is a Grignard reagent formula? R, when Rx reacts with a magnesium, what you get? You get R Mgx. This is in the presence of dry ether, right? So what is this? This is a Grignard reagent. So here it is. This is the R part in the simplest form. This is the R part. This is Mg, and this is X. So the compound what you are going to get at the end is this CH3, CH2, CH2, Mgi. That's it. So every product A, B, C, D. This is A. This is this is B. This is C, and this is D. This last question you can do as a homework, and you can comment me the answers over here in the comment box.